So we are talking about ions and ionic compounds. That's what our big focus is on today. So we just got done talking about the differences between ionic compounds and covalent compounds. Now we're going to hyper focus in on just our ionic compounds. We're going to start with them first, and then we're going to break off into the covalent ones. So it's important for us to understand that our ions, give me a second. There we go. Ionic bonds create ions. What's an ion, you may say? And of course, the edge is cut off because life isn't fair. These are I's. That is an F. There we go. Our ionic compound forms our ions, and ions are just these charged particles. So we did this earlier in the warm-up, right? When we created the different ions. We determined if metals, they were losing their valence electrons. If they were non-metals, they were gaining those electrons to fill out their valence shell. But it's also important to remember that our ionic bonds form when these two oppositely charged ions stick together to form that bond. So our example is we use magnesium and oxygen, magnesium oxide. In this relationship, magnesium is going to lose its 2 electrons, so it gets a +2. And the oxygen is going to gain those electrons, which gets a -2. And that's how we get MgO. And we're going to work on that today, if we have enough time, where we're going to start working on how we write our compounds. That's our goal. Now, before I was using a term called cation. Our metals in an ionic bond always form the cation. That's because they're going to lose those valence electrons to get a positive charge. That positive charge is based on how many electrons it'll lose in the charge. So magnesium is in group 2, meaning it has 2 valence electrons, right? So it's going to lose those 2 electrons to get that Mg+2. If I look at lithium, the top of my alkali metals, that's in group 1. It's going to lose that, and so it has 1 valence electron. And it's going to lose that to form Li+1. But whenever I see that plus, I'm thinking cation. And a way to help you remember your cation, thank you, ma'am. Someone's out right now. If they come back, you can. We're going to draw a little kitty cat to help us remember. Little nose, little curl, give it some whiskers. Now, the way we're going to remember this is that for cations, our cat is going to have pluses for eyes. Kind of giving a Coraline feel for it. But it's a cute little way to remember cation. We see the cat's face with the plus signs for eyes. That's the takeaway here. When I think cations, I think of my cat. That's why we draw the little picture. Now, if on the quiz or test you draw a little picture, I'll think it's cute too, and it might be the way that helps you remember that cations are the positive ions. Why? Because we got the pluses for the eyes. Can I move on to the next one, guys, or we need a second? I know sometimes I rush. I see a lot of people writing, so I'm going to give you guys a little bit more of a second. Ooh. All right. All right, I'm going to move on to the next one. Keep in mind, guys, I'm recording this. I'm going to be putting this in your folder today, so that's why you have access to it. So, if a metal forms the cation, our nonmetals are going to form an anion. Because our nonmetals gain enough electrons to get to that 8 valence shells. 8 electrons in that valence electron shell. Because I'm adding electrons, because remember, my protons are positive, right? Protons are positive. My electrons are negative. And my neutrons are neutral. When I add if I add more negative subatomic particles, it makes my overall atom negative. If I take away negative subatomic particles, it becomes more positive. But our nonmetals are going to form an anion. If a cation helps us remember by making a cat, what do you think an anion is going to be? It's another 3-letter animal. That starts with A-N. I'll give you a hint. There's more of them on the planet than there are humans on the planet. Ants. Our anion has the negative sign on the thorax of our ants. An example of our anion could be fluorine. Fluorine being a nonmetal, is it going to want to gain electrons or lose electrons? Wants to gain electrons, right? It's a nonmetal, wants to gain electrons. So, fluorine normally has 9 protons. 9 protons. I look at my periodic table, I see that there are no electrical charge on neutral fluorine. So it means that my positive subatomic particles have to equal my negative subatomic particles. So it means E. So 9 minus 9 gives me 0 net charge. But when my electron adds, when my fluorine adds that electron, the number of protons stays the same. Because remember, number of protons is our atomic number. And that's how we identify which element is which. If I add an additional electron, how many electrons do I have? I start with 9, I add 1 more, that gives me how many electrons? Christian, how many electrons do I have if I add 1 more electron? What's 9 plus 1? 10. I'll have 10 electrons. My second number is bigger than my first number, so I'm dealing with a negative 1. Notice, The number of electrons I add is the overall charge to my nonmetals. If I go back and take a look at my cations, my magnesium has 12 protons. In neutral state, I have 12 electrons, giving me that zero charge. But I know magnesium wants to lose electrons. Plus 2. 12 protons minus 10 electrons equals plus 2. I get the same number. It's another way to get to the same place. So I can compare how many protons to electrons I have. Everybody ready to move on to the next one? Okay. So I have an image, and I do believe I put them on your slides. But this is kind of a catch-all, just reminder. So my metals are always going to lose electrons to become positive, forming my cations. My nonmetals always gain electrons, becoming negative, forming my anions. And here's just some basic trends that happen throughout the periodic table. Notice how my noble gases don't want anything to do with losing or gaining electrons. They are happy. These guys right here are the most stable on the periodic table. Because they are stable, they do not need to lower their energy anymore. Now, in experimentation, we can force a couple of these into into reactions, but it takes so much time and energy to force these noble gases to work in something else that is pointless. Overall, the noble gases is where we want to be. It's easier for lithium to lose 1 electron than to gain 7. It's easier for nitrogen to gain 3 electrons than to lose 5. Whichever one is closer, that's the path it wants to take. Notice that we've completely skipped over our metalloids, because depending on what they're reacting with can determine whether they are sharing or gaining and losing electrons. So for the sake of argument, we're just going to kind of ignore them, because the goal for high school Gen Chem is for us to see the trends. We're going to get into some exceptions, but we're not going to get into all of them, because there's more of those than there are rules in chemistry. So now it is your turn to work which ions are going to form. So you're going to need your periodic table for this. Let me ask the first one. If I'm looking at Rb, rubidium, where do I find rubidium on the periodic table? Is it a metal or a non-metal? It's a metal. We find it number 37, right? Because it's a metal, is it going to gain or lose electrons? It's going to lose, right? That's our rule. Metals always lose them. How many electrons is rubidium going to lose? 1, 2, 3, 4. 1. Rubidium is number 37 on the periodic table, right? So if I take my periodic table, I'll push that up real fast. I see it's in group 1. That means it has 1 valence electron. It only has 1 electron to lose. So what's its common ion then? Rb what? Plus what? 1. Now, we'll see it as Rb plus 1. Sometimes I will omit this, guys. This is just how I was taught to do this. Rb plus. So when there's just 1, sometimes you'll see me write it either plus 1 or plus. They mean the same. I'm trying to undo this in my head and have the +1 to help you guys out so you guys can see it better. But I want you to go ahead and work through the rest of them on your table. Table in your book. And what we'll do is we'll come back, we'll check everybody's work at the end, and we'll move on to naming our compounds. Excuse me. Writing our formulas for our ionic compounds. Just come around and take a look at them. Jennifer, we'll come around and we'll see if you got anything written down. If you do, I'll let you use the restroom. Yeah, the paper. Well, I said anything. Come on up here, get the paper. There you go. Hey, that's to make mistakes again. Make mistakes on the quiz. Good job. Good job. Good job. All right. All right. So, as those who are still working on those last couple, I see that some people are just like on the last two. You guys can keep working on that. I'm going to grab attention to everybody else. Potassium. Potassium is going to be a metal or a non-metal? K. What's K? It's going to be a metal. So, does that mean it's going to gain or lose electrons? It's going to lose them. How many electrons is potassium going to lose? One of them. It's in group 1. So that means it's going to be K what? Plus 1. Oxygen. Metal, non-metal? Non-metal. Is oxygen going to gain or lose electrons? It's going to gain them. How many electrons is oxygen going to gain? It's going to gain 2 of them. So that means it's going to be the common ion is O what? Minus 2. Aluminum, metal or non-metal? It's a metal. Oh, there we go. Do aluminum is over here on my periodic table. Remember, my bold line separates my metals from my non-metals. If you're sitting on the stairs, you are my metalloids. So just because it's off to the right doesn't mean that it's a non-metal. Good catch. So because it's a metal, gain, lose electrons. Lose them. How many is it going to lose? 3. It's in group 13, also known as 3A. So it's going to be Al plus what? 3. P. So now we're looking at phosphorus. Phosphorus, a metal or non-metal? Non-metal because it's a poser. It's a poser, it's not metal. Nobody? All right, I'll see how it is. Gain or lose electrons? It's going to gain electrons. How many electrons is phosphorus going to gain? It's going to gain 3, right? So that means that my ion's going to be P what? Minus what? All right, and chlorine, so we're doing so well, it's a non-metal, so that means that's going to gain 1. It's only going to gain 1 electron because it already has 7, right? It's one of my halogens. So that means that it's ion Cl minus 1. So I'm going to leave that there, so those who need to write it down have a chance to scribble it down real fast. All right, so we are all almost. So when it comes to ionic bonding, here I have my sodium and my chlorine atoms. Sodium is in group 1, only has 1 valence electron. Chlorine has 7. Because of the electronegativity of chlorine being stronger than sodium, the 1 valence electron is going to be ripped away from sodium and given to chlorine, making sodium my cation, making it slightly positive. With that additional electron, my chlorine becomes slightly negative, my anion. And because of this reaction, they're going to be pulled closer together. Charges are going to pull them closer to one another. And that's how we form our ionic bond. Now, here's the thing. Just because we could see that, we can name the cation, we can name the anion, we need to know how to write these things. And that's what we're going to look at on the next one. Writing a formula for ionic compounds. There's 4 steps that we're going to work through. I have my example here of magnesium and chlorine. But the first move is to write the symbol and charge of the metal, the positive ion, also known as the what? Say cation or anion? The metal, it's going to be cation or anion? Cation. Step 2, write the symbol and charge for the negative ion, the non-metal, or also the anion. Determine the ratio that balances and cancels out the charges. Write the chemical formula without the charges using the subscript to show how many you have of each ion. So our example here is magnesium and chlorine. We know from extensive review, magnesium is going to lose its 2 valence electrons. So that's why we're at Mg plus 2. Chlorine can only form a -1 ion. 2 does not equal 1. So I'm looking at my ratios now. 2 does not equal 1. I'm going to add one more chlorine. 2 equals 2. Then I'm going to rewrite it as MgCl2. We're going to do a couple examples. I'm going to give you guys a chance to write this down real fast. Then we're going to do a couple examples before we move on to the next page. But this is effectively where we're going to hit the pause button today. So we're going to practice this a little bit. Let's say I wanted to do another example. Let's do beryllium, also known as Be, and oxygen, also known as O. First step, we need to write the symbol in charge for the positive ion beryllium, Be. What's the ion charge on Be? Looking at your periodic table. It's going to be a plus what? Give you a hint, beryllium is number 4 on the periodic table. What's the charge on Be, the ion? Was it? 4 is the atomic number, but what ion is beryllium going to form? It's going to be a +1, a +2, a +3, or a +4? It'll be a +2. Why? It's in group 2, so therefore it's going to have a +2. Oxygen. So number 2, write the symbol in charge of the negatively charged of the negative ion nonmetal. Oxygen is going to form which ion? -1, -2, -3, -4. So it'll be a -2. Determine the ratio that the balance is and cancels the charges. So total number positive charge has to equal the total charge of negative. Does 2 equal 2? Does 2 equal 2, guys? I can't see you guys shake your head yes or no because I need an audible response. Does 2 equal 2? Yes, it does. So, step 4, write the chemical formula without the charges, using the subscripts to show how many of each ion. How many berylliums did I use? 1. How many oxygens did I use? 1. Beryllium oxide. Now let's do one where we have to mix things up. Let's look at aluminum and oxygen. Step 1, write the symbol in charge of the positive metal. So that's Al. What is the ion charge on aluminum? Plus what? Was it? +3. What's the ion? 2. Write the symbol in charge of the negative ion for the nonmetal, oxygen. What's my negative charge for oxygen? It's literally on the board. -2. Does 3 equal 2? No. Which one do you think I should add more? More oxygen or more, more aluminum or more oxygen? Let's try oxygen. Does 3 equal 4 now? No. So I gotta add something else, right? Try adding the aluminum. Al +3, because it can only be +3. Now I'm 6. 6, 4. So is that equal? Does 6 equal 4? Which one do you think I need to add more of? Aluminum or oxygen? If 6 and 4, which one do you think I need to add one more of? The oxygen. O -2. 6, 6. 6 equals 6, right? So that was step 3. Determine the ratio and balance cancel each other. My positive charges +6 have to balance out with my negative charges, 6. So, number 4, write the chemical formula without the charges, using the subscripts to show how many you use of each ion. How many aluminums did I use? I used 2. How many oxygens did I use? 3. Aluminum oxide is Al2O3. So, this is what I'm going to have you guys do. I have a types of bond worksheet that I'm going to give you guys for homework. It's just the front page. I want you to work the front page. I want you to try what you can. I'm going to have this posted up here for you to review. But I want you to give it a shot. And bring it back to me. Wait, don't, not this one. This one. This one's a lot easier. Alright. So, bring this with you on Thursday. When I see you on Thursday, we're going to do a little bit more practice with this, and then we're going to get into the lab. So it's a fun lab. We're going to use a little bit of electricity. We're going to do it safely. And most of all, we're going to have fun. At least I think we're going to have fun. We'll see if you guys think it's fun. But that's the end of today. So I'm going to hit the stop button here.